Okay, so let's go directly into this this slide directly. Okay, here is actually the let me kind of like now let's look at the business logic first. Okay, so business logic is kind of like, of course, every business has a different logic, right? But basically, you want to make some decision, right? And with this decision, you will expect some outcome, right? Okay, that is business decision, and that is the purpose of business analytics, right? Right. We want to analyze data so that we can make a good decision that will lead to a good outcome, right? That is the purpose of business analytics. So you can actually write program to kind of like simulate your business logic, right? When you have this decision and you can actually write a code, right? Usually the business logic is not rocket science, right? It is usually very simple. If you are familiar with your business logic, right, with the programming technique that we have learned in this course, should be good enough for you to like write a program to estimate the outcome given the decision, isn't it? Right? Isn't it? Business logic, as I say, is usually a simple process, right? It's not rocket science, right? You don't need to use the calculus. You don't need to use like the differential equation, that type of things, right? Simply use a simple code. You can actually realize your business logic by program, right? And after that program, given the decision, you can predict the expected outcome, right? That is the way business analytics is, right? But there's a problem, right? There are uncertainty, these pink things. See, there are uncertainty within this business logic, right? So for every customer, we can actually predict the probability that they will buy next week, right? But it's not sure, right? Okay? So in your business logic, there are some, if in your business logic, usually there will be a lot of uncertainty, right? And you need to actually make decision with the existence of this uncertainty, right? And that is why probability come into play, right? Okay? So we learn probability. There's one very important concept. Probability cannot eliminate the uncertainty, right? But it is only a way to describe the uncertainty to make it estimatable, right? Okay? I mean, probability will not remove uncertainty, but it gives you a way to calculate the uncertainty, right? Make it calculatable, right? So with the probability, you can actually, given the decision, you can actually calculate the expected outcome, right? Okay? That outcome will not come out with certainty, right? But you can actually, as long as you know the probability, you can know the expected outcome, right? And that is why we want to use data to predict the probability. And the way we are using data to predict probability is called modeling. Is that clear? Okay? So today I'm going to walk you through a data case, an interesting data case, actually, quite interesting, as you will see. Okay? How we use data to build model, how we use model to estimate probability, and how we apply the probability in the business logic so that we can make an optimum decision to get the maximum outcome. Let me say it again. Today I'm going to walk you through a case, right? How we are using data to build model, how we use model to predict probability, and how we can use probability with program, okay, to evaluate the outcome of a business process, so that we can determine the optimal decision for maximum expected outcome. Okay? Is that clear? Okay? And that is basically what we are going to do in the second half of of this course. You got me? Okay? Because there are many different type of model to use data, right? So we will go into detail, and hopefully at the end of this course you will have a very good idea about how this would work. Okay? Okay, now let's, without further ado, let's go into RStudio. Now, today we are using Unit 8 already, okay? Unit 8. So go to Unit 8, and you will see, you go into that, sorry, this should be 8, right? It's not 7. There are two material, right? So this is just a slide, and what's important is the zip file. Download the zip file, unzip the zip file, and under your code folder, you should have a 08 intro probability folder. Get it? Need more time? Get it, right? Anyone need more time? You get it, right? So go into that intro probability folder. There are a lot of files. Don't be freaked out, okay? So just go to the file called EN-FAST2A. This one, EN-FAST2A.rmd. Now, and open the file. Of course, you want to set this as the working directory. Now, if you open this file, en2a.rmd, you will say that here are different, right? Instead of neat, you will see a wrong document here. See that? Anyone come to this point yet? Need help? Yes. EN-FAST2A.rmd. In your RStudio. Okay? Open this file. And you will see actually,
I only have either NFAT2 or NFA2AX, but not 2A.
Not 2A?
Not 2A. 2AX or 2.
Oh. Let me see what's the difference between 2 and 2A. So let's use EN2. Okay, let's use EN2. So everyone has the EN2. Okay. And then let's run this document. Okay? Here's the run document. Well, if you are the first time running this document, it might need to install some packages. Okay? So let it install. So if everything runs smoothly, you will see something like this. Anyone see this screen yet? Not yet. They are installing something, right? That they install. See it yet? It works. After you install the package, maybe you need to run the document again, right? And with the package, you should see something like this. Anyone see this? Please raise your hand. No? Can TA go? You see this, right? No? So what's the problem?
There's no package called the Flash dashboard.
No package called Flash dashboard?
It says there's no package called emo.
Oh man. That's okay, let's do it this way. Okay? Let's do it this way. Do it another way. Now you go to the unit page, okay? Go to this unit page, okay? Then scroll down. Here is interactive Shiny app. See that? See that? Click this one. Okay? Go to Unit 8, the page, okay? And then scroll down. Here is interactive Shiny app. And click this one. You should see something like this, right? Okay? Get it? Okay. So forget about the RStudio. Okay, forget about the RStudio. Let's go to your just go to the unit page and then click this one. Interactive Shiny app. So anyone have any difficulty to see this page yet? See this page, right? Okay? So anyone still cannot see this page? Raise your hand, right? Anyone cannot see this page, raise your hand. TA, can you go help? You just go to the unit page and click the link, right? Should be very simple, right? Get it? No? Why? Have you go to this page yet?
Yeah.
Yeah, and click this one. Just click this one.
Yeah.
And what happened?
the site is not available, it takes too long till then the URL code responds.
No response, but
I'm connected to the internet and all the other things.
so strange.
Yeah, connect to the internet. This should be the result. This should be the result. Yeah. Yeah. That's exactly the same.
No? Okay, it's very, very strange. So let's forget it. Okay, forget it. So we may have to use the, sorry?
We can look at your screen, but that's as well.
Sorry, yeah, look at the screen. Okay. Now, actually, this is our program, and it is in the format of Shiny app. Okay, so it's an app. You don't need to write program, right? I already write a program for you. Okay, so I just want to demonstrate this process in this application. You don't need to write program. Program is already written for you. Okay. So it starts with the story. Have you ever go to the Yellowstone National Park in the United States? You know that there is a national park called Yellowstone National Park, right? And within the Yellowstone National Park, there is a fountain, intermittent fountain, right? It looked like this, right? The fountain is like it's intermittently would erupt and then stop, and then erupt and then stop. Okay, and this fountain is very very famous. It's called Old Festival, right? So people go here to see the eruption, and you need to wait. Now it starts, right? Now it starts, right? And then you can actually like go higher and higher, okay? And then after a while it will stop, right? And if you wait another another hour, it will erupt again, right? Okay. So this is an uncertainty event, right? We know that it will erupt and it will stop and then it will erupt again, right? But we do not know how long it will erupt. We do not know how long you need to wait before the next eruption, right? So this is the uncertainty that we are facing. Although we are not sure about how long it would erupt, but we will have some historical data, right? When we have some, for example, we have some historical data. The first event is like it erupt for 3.6 minutes, and then wait for like 79 minutes, and then next eruption is like 1.8 minutes, and then wait for 54 minutes. And then if you do some historical recording, you will see that this is the time of eruption and this is the time of waiting. Okay? So in total there are like 272 eruption events. Okay? So we have some historical data, right? Then we want to look into this data to get an idea about the time of eruption, isn't it? Right? So after you have this data, and keep it in the data frame, we can do a summary, right? So you can see that the average eruption time is 3.4 minutes, and the average waiting time is like 70 minutes, isn't it? Right? So it kind of gives you an idea about that most of the eruption is around 3.4 minutes, and most of the waiting time is about 70 minutes, right? You can use actually you can use the average to you can treat average as the expected value, right? Okay, but if you do that, in fact it's incorrect. Okay, so if we draw all of this point, right? Use the eruption as the y axis and use the waiting time as the x-axis. Okay, if we do that, you will see that actually they are two type of eruption, right? Okay, this type of eruption, they are actually have a shorter waiting time and shorter eruption, and this type of eruption they have like longer waiting time and longer eruption, right? Actually, if you look around, the mean is actually here, right? The mean of eruption is about like 3.5, right? Actually, very few eruption event is around 3.5, right? So using statistic to predict the future is not a very good idea, isn't it? Right? This is to tell you that when we have the historical data, and if we only do a very simple statistic, something like just take the average, right? It may give you an incorrect estimation, right? A better way is to do a chart, do a visualization, right? Visualization helps us to see the pattern, right? To see the structure within the data. So you can make your judgment better, right? Isn't it, right? So you can see that there are two types of eruption, long and short, right? But the problem of the problem of visualization is that it is very difficult to like quantize the probability, right? If I want to see that the probability of eruption time between 3 and 4 minutes, if I want want you to predict the probability that next eruption is within 3 and 4 minutes, right? It's very difficult to see it in this chart, right? That's why we need model, right? Model is a mathematical formulation, yeah, to help you predict the probability by historical data. Predict the future by historical data. Basically, you use historical data to build a model, right? So, in the assumption that the future would be similar to the history, right? So we can predict that what would happen in the future. Okay, this is too abstract, right? Let's take a look at how it works. Okay. First of all, let's this is interactive. So let me let's do it this way. Right? Let's unclick all of the checkbox here, and also move the time period. The 2n can be, this is the slider bar, right? So move the slider bar, move 2 of the slider bar marker to the left hand side. You will see something like this. Everything is empty. You get this point yet? No problem, right? You can do that. Okay, so as I say, a model is a mathematical representation of a variable. Now, so far we are the variable that we are interested in is the time of eruption. Okay, in minutes, right? So so in this case, we are interested in the eruption time. So the first thing is we can actually show the eruption times if we click this checkbox, you will see that there is a marker, right? For every eruption time, there is a marker here. Okay. Okay. So this is the first way to show the data, right? Okay. And the second way to show the data is histogram, right? Let's click histogram. You see that? This is histogram. Okay. And actually, when we do the histogram, we use histogram a lot, right? To see the distribution of this variable. Okay. Because eruption time is a numeric, is a continuous variable, right? So in order to see the frequency, first of all, we need to divide the domain of this variable into a fixed length bin. Every bar is a bin, right? Okay, and you can actually determine how many bin you want to have. If you have a lot of bin, you can use this slider to determine the number of bin of this histogram. Okay, you see that? Okay, so if we use a lot of bin, the model, we can say that the histogram is a model of the data. Okay, because it helps us to see the distribution of the variable, right? So histogram is a model of the data. But when we are using histogram, we need to determine how many bin we want to have, right? You can use this slider to determine the bin, the number of bin you want to have, right? So actually, the more bin that we have, the more detailed the model is. Okay? Isn't it? Right? See, actually, if you use a lot of bin, the model will be very detailed, right? If you use a smaller number of bin, the model will be simpler, will be easier to read, right? So the problem is how many bins should we have? Okay, and that by itself is a very difficult question to answer, right? Okay, now in this course, the simplest way is that if you make a model too detailed, what would happen? You will see something like this, right? You will see this what we call glitch. Okay, because if the model is too detailed, it will become too specific. It will become too similar to the history data, and they would lose the general. It would not be general enough to represent the future, right?
Professor, what is the meaning of density of probability? Is it just probability, or is density of probability something different than probability?
I will explain that later. Okay, I will explain that. But so far, we can you will see that actually in the y-axis of a histogram, they sometimes they will use density, sometimes they will use frequency. Okay, and the shape, either density or frequency, the shape of the histogram is exactly the same. It's just a different unit.
I only have one question. Because the data point on the histogram with the most maximum density of probability, how can it cross one? How can probability?
No, density is not the same as probability. That's one thing that I need to explain later on. Okay? Density is not the same as probability. They are two different things. Probability cannot exceed 1, but density can. And it will. Sometimes it will. Okay? So I'll explain that later. But for now, I just want you to understand one concept, right? When we are building a model, we can build simpler model, and we can build a very complicated model, right? And actually, you don't want to build your model too complicated, right? If you do a model too complicated, you will see some of these things. These things are actually not real, right? They are actually just specific to this set of data. The data that we have is actually a sample, right? Isn't it? We do not have all of the data. We only have a sample of the data, right? And if you build your model that too specific, too close to the sample, it will lose the generability, okay? It cannot be generalized to represent the future, right? So usually we will reduce the number of bin so that we do not see this type of what we call glitches, right? So we reduce them. Yeah, and this is a very nice model already, okay? A nice model should be reasonable, right? Isn't it? This is a very reasonable kind of model, okay? See that? Okay. So we can use this histogram to estimate probability, but there is one problem, okay? When we want to use a histogram to evaluate probability, usually we will use a called CDF, right? Cumulative density function, okay? If you are not familiar with that, don't worry too much, right? I'll explain that later. Okay. So when you are using the like this CDF, you will see that because the histogram is actually kind of like a discrete type of model, right? Because it's a bar after a bar after another bar after another bar. So they will have this quantized arrow, right? That go with this histogram, right? So usually, today we do not use, when we want to evaluate probability, we don't use histogram, right? So in the old days, when computers are not so popular, when we do not have computer, we use histogram to evaluate the probability. But nowadays we don't use this anymore because histogram has these problems of quantized error, right? So usually today we are using this like smooth density function, okay? So instead of using histogram, we are using the a smooth continuous function to model this variable. Okay. Now how to do the model is not it's not important yet. Okay. We will go through that later, right? How to build model is we will have a few weeks to tell you how to build model. Now for now, let's assume that the model is kind of like a black box, right? In R, you can actually, given data, it will build a model for you. But before it build a model for you, again, you need to choose the bandwidth. If you set the bandwidth very low, as you can see that the model is like kind of very complicated, and it is very, very specific to the sample, right? And if you choose it this way, well, it would be too general, right? Okay, it do not have the sensibility, right? So usually I would say that a probability of about 0.5 is a good choice, okay? So it is not too complicated, right? And it also has the sensibility to refract the sample, isn't it? Right? Okay? For now, we don't have the time to teach you how to choose the optimum complexity yet. I just want you to have the concept that from data to model, usually there is a method. Okay, histogram is a method. Density function is another method. Okay, and when you are using data, using the method, usually you need to specify the complexity you want to use. Okay, and if you don't specify the complexity, there is a default, right? At this point of time, actually using default is good enough. Okay, so in this case, let's say that we are using a density function with bandwidth of 0.5. Okay. Okay. So don't worry about how to build this model yet. We will learn that later, right? Okay. But before we can use data to predict probability, we need to build a density function as a model to predict the data for us. Okay. So as long as we have the density function, we know that we can use this density function to evaluate the probability for us. Okay? So now we can evaluate the probability that the eruption is between 2 and 3 minutes. The probability is 17.7. Actually, the area behind this density function, right? The area behind this density function is the probability, right? Those who already learned probability should learn this already, right? Okay? So with this density function, in R, there is a function that helps you build the density function, right? So don't worry about that. Just give it the data and specify the bandwidth, and then you will evaluate this function. As long as you have this function, and you can actually, for example, the probability of an eruption between 2.8 and 3.8 is just 10%. See that? You can move this. So 2.8 to 4.4 is 3.71. You see that? Okay? So you use data to build a model. The purpose of the model is after you have the model, now you can evaluate, now you can estimate the probability of future event. Okay? Like this one. Okay? So suppose that we are already built a model for this data, density function and 0.5. Okay? We can determine whatever for example, what is the probability between 4 and 5? Anyone? You can try now. What is the probability that the next eruption of O festival is between 4 and 5 minutes? It's easy, right? Just use this slider. Raise your hand if you get the answer. How many? Okay. Say it. Yeah.
40.8.
So how many?
40.8.
40.8. Okay, let's see. 4. What? 40.8.
40.8. Yes, that's
What did I say? Between 4 and 5 minutes?
yeah, like the different bandwidths.
Sorry?
We use different bandwidths.
No. You should tune the bandwidth to like 0.5.
Okay.
Yeah.
46.1.
46.1, right? Bandwidth is important. Okay. So before anything, just like choose your bandwidth to 0.5. Otherwise, it will be different, right? Okay. Now you see that the complexity is important. Usually there is a default, right? And at this point of time, using default is good enough, right? But because we do not have default here, right? I want you to set it to 0.5. Okay. Okay. So now you can evaluate the probability of next event, right? Let's see how we can use that in the business scenario. Okay? That is the next thing that I want to demonstrate. Okay? Now, if you are a tourist helicopter company in Yellowstone, right? So your business is related to you are a helicopter company, right? Okay. So your performance is related to how good you can predict the eruption time. Okay. Okay. So let's make the business logic simple, right? Say that if your business scenario could be simplified as a game, I simplify your business scenario as a game in which you can like bet $30 on the consecutive 60 minutes, okay? And you will win $100 if the next eruption time fall within this period, okay? You choose a consecutive 1 minute, okay? And when you choose this, if you choose to do that, then you need to pay $30, okay? So, and if it does, right? If the eruption time does fall within this period, then you will win $100, okay? So the question is whether you want to join the game or not, okay? This is the first question, okay? The second question is, if you join the game, which time period would you choose, right? You want to choose a 1 minute period, right? So actually you can slide the slider like this, okay? So first question is, can you do you want to join the game, right? Do you want to bet the $30? That is the first question, okay? And the second question is, if you bet, then which time period should you bet, okay? The third question is, okay, if you bet, and then what is your expected return, right? I mean, let's go here, right? First thing, you want to determine whether you want to join the game. Second thing, if you join, which time period would you want to bet? The third thing is, in the period that you choose, what is the expected value of the game? Which means that what is the expected return? Net return, okay? Deducted by the $30 cost, okay? What is the net return of the expected value? Can you answer the question by a density function of 0.5 bandwidth? Let me focus it again, right? 0.5 is important, right? Okay? Now use this interactive program. You don't need to write a program, right? Model is there already. You only need to set the bandwidth to 0.5, okay? Then you can change your slider, right? And you want to answer these three questions. Can you do that? Now, I want you to try to solve this problem within the team, okay? And when you have a answer, just raise your hand, okay? You have the data, now you have the model, now you have the business scenario that you need to make decision, right? So how can you use the model to predict the probability to make decision in this business scenario? That's what this three questions all about. You already did it? Okay, okay. That's wait for a while. Okay, let them have some time. Yeah.
Professor, right now we only need to answer the first three questions.
Sorry?
Right now we only need to answer those three questions.
Yes, only the three. Yeah.
outside and you don't know. Right.
So think it this way, right? For every consecutive minute, you actually can estimate the probability, right? Okay, and if you bet on that period, you will need to pay $30. But you have this probability to win $100, right?
Yeah, so you want, yeah, we have,
You have the answer
yeah,
already.
we have discussed it.
Okay. How about that, Tim? You got it? No? See, the logic is like for every consecutive minute, 1 minute, you know its probability, right? So if I bet on this 2 to 3 minutes, I have a 17.7 percent of probability to win $100, right? So the expected value of winning dollar is 17.7, right? But you need to pay $30, right? So do you want to bet on this minute? You don't, right? You don't. So can I do this here? If I set the point to 35 to 4.5, the probability that next eruption void within this period is like 38.7, right? Isn't it? So you have an expected value of how many? Because you will win, you have this chance to win $100, right? So the expected value of this winning money is 38.7, and your cost is 30. So do you want to bet on it? You want to do that, right? So let's see. What is your answer? Like
17.7. From the period 3.9 to 4.9.
so do you want to join again first of all?
Yeah.
Yes. And then what is the time period that you want to bet on?
From 3.9 to 4.9.
3.9 to 4.9. Okay?
Yeah.
And what is the expected value of the game?
17.7.
Sorry. 17.7, right? How did you calculate that?
It's 100 times 47.7%, which is 47.7, and minus 30, you get.
Yes, that is the logic. You get it? No? Well, how about this team? Do you have the same answer?
Yeah, we have the same.
You have the same answer, right? So the point is we want to bet on the one consecutive minute, 60-second period, right? So we want to find the period that has the highest probability, right? So this is the 1 minute that has the highest probability, okay? So and the probability is 47.7, right? So if I bet $30, I have the I can expect that I will win 47.7, right? So after deducting the $30, the net return, the net expected return is 17.7, right? You get the point? Isn't it? Okay. So this is a simplified business logic, right? If you have a model that help you to evaluate the future event, to estimate, to predict the future event, then you basically can use this model to help you do business decision easier, right? Okay. Now let's look at the second scenario. Now, the game rule change. Okay. Now you can place like you can bet $5 on. You can bet $5 on any 10-second period. Okay. still you can win 100 if the next eruption time fall within the bet you choose. Okay. So for the maximum expected value, how would you place your bet? And what is the overall expected value of the bet? Now, it's no longer that you want to choose only one 10 second. You can actually choose multiple 10 seconds, right? Okay? So far it's multiple choice, okay? It's a little bit more complicated, isn't it? Right? See, if you want to use the slider bar and trying to answer this question, it would be very, very difficult, right? Isn't it? Right? Then you need to use program, right? When the business scenario is becoming more and more complicated, you no longer can use this like kind of like slider bar to help you answer the question. Then you need to write program. Okay? And let me show you how we can solve that within the R environment, right? Okay? When the scenario is like this, it become more complicated, then it will be very difficult to try to do it interactively, right? So you need to write program. So you need to combine data, combine probability, combine programming to do the analysis, isn't it? That's why we emphasize that modern business analytics is the combination of data, probability, and program. Okay? Now let's go to our R Studio. Let's open this Phase 2AX. 2AX. You do have this one, right? 2AX. And then along with this 2AX, there should be HTML. Okay? Let's look at the HTML first. You get this one? Get it, right? Okay. We do not have time to like go into the detail yet. But again, today is just kind of like kick off the second half of the course, just to get you familiar with this process. Okay? So let's now this is the scenario that we are doing right now, right? Like 10 seconds, you bet $5 on any 10 seconds. You can do multiple choice, okay? And again, you will win. Still, you will win 100 if you, right? Okay. The next eruption would always happen in one of this 10-second period, right? But so right now you need to like let's see here, right? Right now you need to like, this is the starting time, this is the stop time, right? Because the unit of the data is minutes, okay? The unit of the data is minutes. So 10 seconds is 1/6 of the minute, okay? So this is just 1/6 of the minute. See that, right? So for every 1/6 of the minutes, I want to evaluate its probability and its payoff. You see that? Okay, so the point is, I want to find out all of the 10-second period that has the positive payoff, expected payoff, right? If the expected payoff is negative, then you don't want to bet on it, right? If the expected payoff is positive, then you can bet on it, right? So at the end, if you bet on all of the period that have the positive payoff, right, and you add it up, right, then you actually can have the maximum expected payoff, isn't it? Right? So the logic here, it becomes that you want to evaluate the probability of every 10-second period, right? And if the probability of that 10-second period, okay, if the net payoff is like more than 5, right? The net payoff, right, is more than 5, then you can bet on it, isn't it? And if the net payoff is less than 5, you don't, right? That is the logic of this business scenario. So how can we do that? Now, let me show you. Okay, so this is the way that, first of all, we want to have a sequence, right? Because for every, the start time, let me, we are here, right? So now, first of all, we need to see the period boundary, right? We want to set the period boundary. So we have a sequence. This is from 1 minute to 6 minutes, and every 1/6 of the minutes we, right? 10 seconds, right? So we just set the boundary and put the boundary in X. So now in X we have like, so every jump is like 10 seconds. See that? So this is the boundary of every 10 seconds, right? The next thing is like, we want to write a function so we can like, kind of like calculate the CDF, the cumulative probability, okay? Cumulative probability from the low end to the I will explain this later, right? When we teach you the PDF and CDF type of things, okay? So well, the point is like this, right? Sorry. Okay, it's a little strange. If we want to calculate the probability of every 10-second period, right? A way to do that, a better way to do that is use like this, what we call CDF, right? For those who already learned probability, you should have the concept about what is PDF and what is PDF, right? So the way to calculate probability is, first of all, you calculate the CDF function, and then you actually set the boundary. The boundary is actually like set by these two sliders, right? So you want to know the probability instead of doing integration, because integration is like not easy to do, right? So usually you will use this CDF, right? And use the CDF is actually increasing function, okay? So if you want to know the probability that fall within this area, you just use the CDF of the right boundary deduct the CDF of the left boundary, right? Okay. Now, if you do not familiar with this one, don't worry too much yet, okay? So there's a way that we can, this is the way that we can like calculate the probability in each of this period, okay? So we do a data frame, right? What? No mutate. Okay, so use the program. We actually can see, we can like try to evaluate the probability in every 10 seconds. See that? Right? So for every 10 seconds we know the probability, and because the probability here is very low, right? So the net payoff is negative, right? So as long as the net payoff is like as long as the probability is high, right? High enough, then you will start to see the payoff coming up, right? So let's see how we want to, the expected payoff is actually 100 times the probability minus 5, right? 5 is the cost, right? So as long as the expected payoff is larger than 0, right? We can actually, right? See, we can actually place a bet on it, right? So as you can see that, these are the bets that we can place, right? And if you want to know the total expected payoff, if we bet on all of this 6 minute period, then we can see it's 24.34. You see that? Okay. Now you can bet on multiple 10-second period, right? And by combining probability and program, okay, you can try to emulate a more complicated business scenario, right? Okay, and get the optimum result, right? See that? Okay. So if you do not know how to use probability, or you do not know how to write program, then you cannot answer a question like this. Okay. It's very difficult if you try to do this calculation by hand, right? Okay. You may be able to do that in Excel, but it's a lot easier if you can do it in R, right? And that is the reason why we want to that is the rationale of this process. You see that? That is the rationale of this process. Okay? We have data, we build model. The reason that we use data to build model is we want to predict the future. Okay? Because in the future there are uncertainty. We are not certain about that, but we know the pattern, right? We know its distribution function. Okay? We know that if the future is similar to the history, then we can use this model to predict the future. Right? Now, as long as we have the prediction, as long as we can like kind of like compile our business logic in program, then we can simulate the decision and try to find the optimal decision for the best outcome. Of course, the best outcome will not happen all the time, right? It's just the expected value, right? See that? Okay. When we say the best expected outcome, it do not mean that you will always produce the best outcome, right? But in the business scenario, if you do it in a large number of times, right? The average value will approach to the expected value, isn't it? Right? Because you are doing business, so this logic is like applying repeatedly every day, okay? Every hour, okay? Even every minute, okay? So when you repeat this business logic many times, the expected value would approach the expected value that we calculated if you did it right, isn't it? That is the logic that we are using data for model, using model for prediction, using prediction with code to optimize our business decision for the best expected outcome. Okay? And that is what we want to do for the rest of the course. Get it? Any question for now? Okay, if no more question, let me. Yes.
Is this the only way we are going to do it?
Sorry?
Is this the only method we are going to use to find the expected? Or like?
No, this is not the only method. We will learn a lot of different methods. Okay? So I just, yes.
Sorry. In this method, we just use two things, like two columns, and then we cannot have more data than two. So one column would be the x-axis and the other column would be the y-axis. Or like
Right, this is a very simple data, so we are basically use only one variable,
one variable.
right? In this case, only one variable is involved, right? But in the real business scenario, you will have a lot of variable involved, right? And that would need a more complicated model, right? There are a lot of models, okay? Like when you have chance to learn business learning, artificial intelligence, okay? They are all models, okay? And functionally, they are all the same, okay? They are like hundreds, thousands of different types of model here, okay? But their function are all the same, but they are addressing different type of variable, different type of scenario, okay?
The goal of using these models is for us to find the chances or the probability that a certain thing will occur.
Usually you will predict two things, right? First thing is to predict probability. How the event of interest, what is the probability of the event will occur, right? It's predict probability. And the second thing is to predict the amount, to predict a numerics value. Right? For example, in the Tafang data case, okay, the first thing is to predict for every customer, we can predict that whether this customer would purchase next month. Okay? So for every customer, if I have a model, I can actually predict for every customer what is the probability that she would buy next month. Okay? And the next thing I want to know about the customer is if she buy, then what is the expected revenue contribution he will generate, right? How much can I expect that she buy from us, right? So basically, there are two things to predict. First thing is the probability, okay? And the second thing is the amount, okay? So two things to predict. And there are thousands and thousands of models, and I can say that most of the model, they are simply predicting these two things. Okay, functionally they are all very similar. Okay, so in this course, I will only teach you some simple model. Okay, but you can apply the same process to all of the model that you learn from machine learning, that you learn in the artificial intelligence courses. Okay.
But Professor, let's say in real life, we have data that's coming for a grocery store, let's say it's for PX1, and we have data coming in every day. So is there a way that a model is, I don't know how to say it runs continuously and you can keep on feeding in new data? And then
Well, that is a very, very practical and very important question, right? So how often would you build a model, right? Basically, that is what you are asking, right? Data would come in like every day, every hour, every minute, okay? So when are you going to build your model? Right? So it actually depends on your planning process, right? If I do the marketing planning every quarter, then I only need to build a model at every quarter end, right? So you don't need to like do the model like every hour. That does not make sense, right? So if I want to adjust my marketing strategy every month, then at the end of the month, after I collect the data, I build a model to predict the next month, isn't it? Right? So how often that you build a model, it actually depends on your business practice. Okay. Any more question?
But let's say I understand that in reality that makes perfect sense, but is there a way to have live visualization of data? That the visualization continuously changes as soon as the data comes?
Yes. There are that's called dashboarding, right? You want to see data is coming in like a data stream, right? And I want to process this data stream in near real time, right? And I can show that maybe every 10 minutes, if I have enough of processing power, right? Because the program is there, right? So I can kind of update the prediction in every 10 months. Every 10 minutes. It's doable, right? And actually, in some financial application, they will do this prediction in tens of seconds, 1/10 of a second. Their computer is powerful enough to do that. You might have heard about a term called high frequency transaction, right? That type of application is more like engineering. You know that financial engineering, right? So that type of thing is more like engineering. It's not like business analytic anymore. It's more like when you do a model in that frequency, then it actually swing to the engineering side already. Okay.
But Professor, like when COVID came, we can take like the example of a grocery store. So when COVID started, the purchasing behavior of every consumer changed all over the world. Let's just take Japan and Taiwan. So during that period, how do we use data how can we predict customer behavior when times are changing?
I don't get your point.
So when COVID started, the customer purchasing behavior changed. Like there would have been lockdowns, the customer would not have been able to go out and buy. So the past data
Okay. Now you're talking about a shock, right?
Yeah.
Well, there's nothing we can do to for this shock, because after the shock, the behavior change, right? So you cannot. Well, there's a premise, right, to use predictive model, which is the future would be similar to the past.
Yeah.
So if there's a disruption, if there is a shock like COVID-19, right, then, well, you would say that the prediction would no longer be valid. Or its accuracy will drop, right? So usually when that happens, you will still use model, okay? But you cannot have too much confidence on the model prediction, right? That's what we can do, right? That's the best that as a manager that we can do. Okay? Anything else? No, huh? Okay, so today we do not have homework, right? Because you just do your midterm, right? So next week we will cover some of the probability, introductory probability, I should say. I do not have too much time to dig into probability anymore, right? But for now, let's just remember this, right? Because if there is one thing that you need to remember in this course, this is the thing that you want to remember, right? We are using data to build a model so we can predict the future, okay? And we need to, like, the prediction is not the same as decision, right? Prediction is one thing. Decision is the other thing, right? Now, in order to turn prediction into decision, you need to kind of write a program, right? According to your business logic, as we have just shown you, right? And the logic would be different from company to company, right? From country to country, right? From function to function, right? From time to time, okay? It changed, okay? So you learn programming so that you can combine prediction and business logic and try to find out the optimum decision that will produce the best expected outcome. Okay? Okay, that's for today. Yes?
Can we all share the full presentation PowerPoint slides together so we can learn each other?
Okay, do you care that if I share them? No? Okay, so here we can share the data to everyone. Okay? Put that in the Facebook or something like that. Okay? Okay, that's all for today. We'll see you next week. Thank you. So again, we won't have a TA session this week. Okay?
So on the side there was like personal assignment. That's not for this week. This is for.
Yeah.
Oh, okay.
It's not for this week.
先走的海底说他因为有考试，所以提早5分钟走。
好，没事。嘿，
老师，我想问你啊，你刚刚上课有说我们在看一个这个图表的时候，
对，这个东西，譬如说你选的是这个0.5，然后你说看太左边就会太极端了，然后太右边就会太平，就看不出什么重点。
对。
那怎么？譬如说我们今天在一个企业里面想要做一个行销，然后想用最少的预算去达到最大的效益，那是要端看那个 plan 的重点是什么，去捞精准的数据吗？事实上，
如果你学到机器学习那边的时候，它会有一个方法帮你选择最佳的这个。
最佳的数据。
对对。
这还
但是
得用机器
但对，那个技术我们现在还学不到那里这样，所以现在的话，我们原则上就看起来觉得差不多就好这样。
先选基础的嘛。
对。
那如果说像假设我们今天企业里面的主管他没有学过这些东西，他们是怎么去判断他们的下一步？譬如他们不知道机器学习是什么，可能是一个商管主管。
对他其实不会 care 你是怎么算的。哦。但是你要跟他讲说，
他可能会听工程部。
对我算出来的结果是什么，
然后他们去判断。
是。
那会出问题就是你的问题。
就是他们可能会参照各个部门的报告的数据去做一个判断，这样。
对，应该是这样。
那他们除了看这个数据之外，他们像主管他们会参照哪些商管里面的因素？老师会晓得吗？还是都要？
没有，其实不一样的产业也都不相同。然后每个人的每个老板的习惯可能也都不一样，
没有一个比如说一个 general idea 去，不管
对你能做的只是说，想办法，对，想办法帮老板把资料准备的好一点，让老板可能比较容易做决策。OK。
然后我想问是那个1.8跟0.5，不是 generally 会比较好的 complexity， 对不对？就是要看这个资料。
对，没错。
它不是一直都是0.5跟1.8。
不是，并不是这样，就是这样。
就是看起来大概是 OK。
看起来你觉得真实的样子大概像这样，事实上有更好的方法，但我们现在学不到那里。这样。
比较数学。
对。
好，谢谢老师。